Let's try out another checkpoint problem. So we have the following graph represents an inequality. So this graph here, and then we want to figure out which of these four inequalities here is represented by our graph. So taking a look at this, it looks like we have something that says we're including points between -3 and 3. So we want to right off the bat know that we have an and statement here since we have this defined range of points. And we can see that we have both points themselves are included. So we want to have definite inequalities here where we're including our -3 and our 3. So the only one that looks like it fits that statement would be B here, where we have the x is greater than or equal to -3 and less than or equal to +3. Allows us to include both of those ends on our graph. So it looks like B is the best bet here. So for number 2, we need to select all the graphs where -7 is included in the solution set to the inequality or equality. So why don't you go ahead and see out of these 5 choices, which of them you think -7 is included as a part of the solution. So go ahead and pause the video now and see if you can come up with answers for each of these, then unpause once you're ready to go over it. Alright, well let's just start working our way through. So with A, we have a single point in our solution. It's shaded in number -7, which means that is the only point in our solution, so it is of course part of our solution. For letter B, we've got numbers that are falling below -7, but we have that closed dot again, so -7 is again included in this solution. For C, we've got the range between -7 and 5, everything that falls in between them, but we have an open circle above -7, so C does not include -7 itself. Now for D, we're looking at the range between -10 and -1. That includes everything that falls in between those. So now, even though there's no sort of circle over -7, we know it falls within that range, which makes it a part of our solution here. And then E is very similar to letter C, where -7 is the boundary point for our range of solution values, but not itself included because of that open circle. So let's go ahead and mark out E. That gives us A, B, D for our 3 final correct answers for this one, which I hope makes sense. But we're just looking for which part -7 actually falls into our solution set here. Let's move on to one last page of examples where we're examining some absolute value inequalities. So with number 1, we're starting out with absolute value inequalities. We want to make sure we isolate the absolute value in order to further solve our inequality. To do that with this first one, let's just subtract 6 from both sides. And that's going to give us x minus 5 is greater than or equal to 21. So now we have just our absolute value bars compared with our inequality. We can split this into 2 inequalities just by taking our middle grouped terms, our x plus 5, and copying down the last statement of our inequality exactly so. So x plus 5 is greater than positive 21. And then we want to check the direction of this sign. Since we're using or here, we're going to use the word or, and then copy down our second inequality, which we're just taking the group of terms in the middle of our absolute value bars, and then this time flipping our inequality direction and multiplying the other end by -1. So this becomes a less than or equal to sign, and now we have a -21, which gives us our 2 inequalities here. And if we want to finish solving for x, we can subtract 5 from each end of these. So we'll get 5 is greater than or equal to positive 26, or 5 is less than or equal to negative 26. So it's just the other direction this time around. So now that we've taken a look at this example, let's try one where we have a less than symbol starting off. So this is fairly similar, where we're going to initially just copy down our statement here by dropping our absolute value bars. But now that we have a less than statement, we're going to combine these into the compound inequality with an and statement. Then again, we're going to just copy down our central grouping and flip the sign, multiply by -1 here to give us our second inequality. The only difference really is that we're switching from and to or just based off the direction of the sign initially. So less than, we're using our and here. Now we can just add 6 to each end in order to solve for our x. And then we'll divide everything by -2 to finish up. Which, only thing to note here is that we should be changing our signs because I divided by that -2. Almost didn't catch myself there. But we're switching the signs, and we'll get x is greater than or equal to -11/2, and x is less than or equal to -1/2. Now let's see what these would actually look like if we're not only just solving for x, but we're actually graphing these absolute values. So I'll start off doing these first two, where now we're starting with a greater than sign, so we're going to make sure this one is combined with an or. And we're just flipping the direction and multiply by -1. We've got our two statements here, which I'm going to go ahead and start solving by adding in some 3's. Then if we divide by -8, we can get a is less than -7/4. So again, just want to make sure we're flipping the sign because I'm dividing by that negative. Now a becomes greater than +1. So we can have an a that falls either below that -7/4 or it can fall above +1. I'll do one more as an example here. So now we still have a greater than sign. We've got 1 minus 4k is greater than or equal to -11, or 1 minus 4k is less than or equal to +11. Now I'll just subtract my 1. And we'll divide by our 4k, or our -4. So we have a negative term again. Just make sure we're flipping the signs. Now we've got both of these worked out, so let's just go ahead and graph these on our number lines to make sure we can accurately represent our final solutions. So for our a, like we said, we can have a -7/4 or a +1, where a can be less than -7/4 but can't be equal to, so we're going to have the open circle, or it can be greater than 1 but not equal to, so again an open circle above 1. Likewise with our second example here, we've got our -5/2 and our +3. Now we're saying that k can be greater than or equal to, so let's use a closed dot here, our -5/2, and less than or equal to, so we use a closed dot here again for our 3 and shade the other direction. Now we can see that we have arrows pointing either way indefinitely across our whole number line. So this is one of those cases where no matter what we plug in for k, we're getting a true statement, which should make sense because we have this absolute value here and we're saying that's greater than a negative number. Well, absolute value bars always give us the positive distance away from 0, so no matter what we put in here, we should always be getting a number greater than -11. So it makes sense this one could be any possible real number here. But now for these last two examples, why don't you go through on your own and work through them, and then see if you can make graphs for each of them as well. And once you've given that a shot, then unpause and we can go through everything together. Alright, so let's give these out a try. Let's add 10 to both sides for this one. I think that'd be a good first start to isolate our absolute value bars here. Now we can divide everything by 9, dividing by a +9, so we can keep that inequality a less than sign here. Now we've got m minus 8 is less than 4, and we're going to use an and to combine that with m minus 8 is greater than -4. So let's add some 8s and give us m is less than 12 and m is greater than 4. So now on our number line, we'll mark 4 and 12. And let's see here, the part that we're actually interested in, we can have less than 12 but not equal to 12, more than 4 but not equal to 4. So we want that region that falls in between our 4 and 12 here. Once more together, we'll start solving this one. So we'll subtract that 10 from both sides. And now we divide by 9, still positive again, so we're not changing the signs. But we're going to get less than 5 here. So we'll get our two statements, x plus 8 is less than 5, and x plus 8 is greater than negative 5. Now let's just go ahead and subtract 8 from each end. So we'll get x is less than negative 3, and x is greater than negative 13. So let's make our number line. We'll have negative 3, negative 13, which we want an x that is greater than but not including negative 13, and less than but not including negative 3. So again, we're shading in between for our and values here, giving us this range of negative 13 to negative 3 for our final graph. Okay, that wraps it up for this video. I hope you all are doing well. Take care, everybody. I'll see you in our next lesson.